Bismillah ar-Rahman ar-Rahim. Alhamdulillah Rabbil Alamin. Let's watch this video for 4.5 minutes, and set the context. People have doubts about the deen of Allah, not because of some intellectual problems or they have a daleel, rather they're different things. So let's start. And the foundations of their aqidah, their belief, is mathematics. Everybody believes mathematics to be absolute and certain. This is what we have been taught, brought up, inculcated. And anytime in my experience that I brought up these topics, it is not that people can doubt what we are talking about, is because this kind of thing actually shakes their belief, so they are not ready to accept it. Rather than looking at the argument, they start finding excuses as to not to accept our argument. So let's start with mathematics today. Mathematics today is what? Is the basis of all modern sciences, right? So this is one of the pictures that we have where the relationship with different branches of knowledge, and where mathematics is considered to be the foundational. I have about 10 pictures like this. This itself is a story by itself. Look at how this picture is changing. This is like in the early 80s, and 1880s. Then you have this. See how the picture is changing now? Now, with the advent of the 19th century, so the change.
In the first picture, what was the idea?
The first picture had only few branches of science, right? And it was a linear relationship. Mathematics at the bottom, astronomy, physics, chemistry, biology, sociology, right? So a very simple linear relationship, one after the other. Now in the second picture, you will see that the levels have increased, and it's still linear. Okay. Now the next picture that you have is no longer linear now. You will see that the picture is changing, and now you have branches. A linear relationship still exists, but is now more of like a branch, a tree. And then in the following picture, we are trying to, it's still linear branching, but we are trying to bring the sciences in terms of how we view life. Now in this picture, now you see we are using Venn diagrams. There's no longer linear relationships anymore. Now the relationship between mathematics and different branches of science is now being described by Venn diagrams, and you will see that the intersection of all this thing is statistics and mathematics. Next picture you will see is even more complex with the development of modern computer science and artificial intelligence. Now use this Venn diagram. Even trying to understand this Venn diagram itself probably requires a degree itself. Now this is another picture of the same thing, and they are trying to describe the relationship between the different branches of knowledge and mathematics. And the main thing that here I want to see how there is a shift from a linear relationship to a non-linear relationship. You can't. Now the next, the educational system try to define the relationship between the mathematical sciences and other fields, and they said that the distinction between core and applied mathematics increasingly appear artificial. So they are saying there's nothing, we shouldn't be dividing mathematics into applied and pure mathematics. We should just say mathematics. Now, why I have brought this up, I'll explain to you later. But the point of this slides here was the relationship between mathematics and other branches of sciences itself is shifting based upon what we have in our how our knowledge is going about, and it continuously shifts. So before I begin, I think we need to understand the history of mathematics before we can actually appreciate what questions we are going to ask in the foundations of mathematics. So for this, I did not prepare separate slides because they would have taken me, many hours. So I'll just briefly describe how mathematics started, and then we can appreciate the questions that mathematics have. So if you will allow me to use the board here. Now, do we have this pen? Okay, it's working. So mathematics basically started this way. Man has two important, from a practical point of view. What is the practical point of view? We need to count, measure, build, right? These are three basic things that everybody needs. So these two, we have what? We had arithmetic, and for this we had geometry. Arithmetic is basically counting, addition, 1 plus 1, 2 plus 1, all that. Geometry is basically the study of shapes. And the first thing that was developed was the Pythagoras theorem to divide. I mean, this is the basis of these things. So now geometry can be basically is what? Lines and circles, right? This is all that it is, nothing more. Now this was developed in Babylonian times, ancient Egypt. The Greeks took it to a more formalized these fields, and along with the arithmetic and geometry, what is another very important thing that man needs? Remember, we discussed this. He has to find direction, and for direction, what do you need?
Reference.
You need a reference. And what is our reference?
Stars.
Stars. Without stars, there's no reference. You can't go from point A to point B. So,
But you can see no reference. There are references. There's a polar references. Polar references.
There can be local references, but on a regional and global level, you have to. This is it. This is locally. Yeah, you can say this building is tall, and then we can do a reference. But if you
set your own coordinates in that case
Check,
locally.
check.
yeah. So this started what? Astronomy. Right? For astronomy, you need a more sophisticated thing than just counting and measuring. What do you need? Trigonometry. Right? So basically, this is what we have. We have these four fields here. We have arithmetic, geometry, and astronomy. This gives rise to trigonometry. Now this was the case. This was there for some time.
So geometry and trigonometry, are they same?
Trigonometry?
Yeah.
Trigonometry is a specialized case of geometry where you study only triangles and So this is basically used for triangulation, right? So now this state of affairs continued for a long time in mathematics, and then we developed spherical geometry and spherical trigonometry. Guess who? Foundations were laid by the Greeks, but who developed these two fields? Muslims. And why did Muslims pay particular attention to these two fields? What was their primary motivation?
The distribution of wealth.
Here, the two reasons were time of Salah and Qibla direction. These were the primary motivations for spherical trigonometry.
Oh, spherical. Okay.
Right? Along with this, the Muslims also developed algebra. This is the new field that came about. And why did algebra came about? Brother Fawad just said, to solve the problem of inheritance. Because to do it arithmetically takes longer. Doing it algebraically takes shorter. Everybody can do it. So this was how this was developed. One other aspect of mathematics people don't talk about, and this is what was your question. I deliberately put just RE just for myself. What else do you think mathematics was also used for? People don't usually go there. When temples, religious places were built, they were built based on mathematics. All the Greek temples, the altars, sacrificial, they are based on some calculations. Mathematics was also used to do also with what? Astrology. Right? The kings they had astrologers. And how did astrologers tell the king what is going to happen? They used basic mathematics, right? They calculate the position of the star, blah, 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 and therefore this is going to happen. This is based on mathematics. So mathematics, that's why I put RE, because if I put religion, then everybody guesses it. Right? तो पॉज कर ले, पॉज करूं? नहीं, मिस कर जाएंगे फिर आप. मैं पॉज कर लेता हूँ. हाँ, रुक गए. चलें, सवाल जवाब कर ले. हाँ, चलें, उसको बाद में एडिट कर दे.
इसमें मैं एक चीज कहना चाह रहा था. ये आपने टेम्पल्स की जो मिसाल है, जो कैलकुलेशन के हवाले से मैथमेटिक्स, ये तो अगर ब्रिज भी बन रहा है तो वो
yes, very good, yes, and there is nothing. Point जो मैं आगे जो जाना चाह रहा था, मैथमेटिक्स और एस्ट्रोलॉजी की वजह से और जो टेम्पल कंस्ट्रक्शन से मैथमेटिक्स का एक रुझान हो गया कि ओह, मैथमेटिक्स हमको रियलिटी बताती है. डायरेक्शन ऑफ थिंकिंग.
एक चीज मुझे बताएं, ये तो बहुत सी चीजें होती हैं, तो डिजाइन वर्क होता है, हम बाहर जाते हैं, ये हमें जो चीजें नजर आ रही होती हैं, कैलकुलेशन तो उसके पीछे होती ही है ना. कोई
इसको कोई डिनाई नहीं कर रहा ना. द प्रॉब्लम इज दिस, जो प्रॉब्लम आएगी जब आप इस मैथमेटिक्स को आप इसके साथ ज्वाइन कर लिया. क्या मैथमेटिक्स,
ये आपने रियलिटी लिखा है?
ये रियलिटी लिखा है. अब मैथमेटिक्स बता रही है कि कल आपके साथ क्या होगा. ये एस्ट्रोलॉजी यही कह रही है ना भाई. एस्ट्रोलॉजी ये कह रही है कि ये स्टार, ये प्लैनेट और ये चीज जब ऐसे करके ऐसे हैं, देयरफॉर कल मेरे साथ हम मर जाएंगे. What is this based on?
assumption.
No, assumption, ठीक है, but it's based on astrology, which is mathematics. So now you have linked mathematics with reality. Right?
कि मेरा एक साथी है, उसने मुझे बताई थी ये बात, वो भी जब वही उसने बताया था कि इजिप्ट का था, उसने बोला था कि वहाँ पे एक वंडर ऐसा, मुझे सुन के बड़ी वो हैरत हुई, लेकिन मुझे अभी इस बात से वो क्लियर हुई बात कि, और अभी की नहीं, वो फेरो के टाइम की, उसने ये बात बताई थी कि उसका जो बर्थडे है कि एक जगह ऐसी है कि साल में एक दिन आता है वहाँ पे, और उस कमरे के अंदर जो है, जो उसका बर्थडे है वो बनाया, उसके अंदर रोशनी होती है बस साल में।
So all the pyramids, ये इसीलिए
364 दिन जो है उसमें वो अंधेरा, वो कमरा बना इस तरीके से, उस वक्त जिस दिन वो पैदा हुआ है उस तरीके से उन्होंने कैलकुलेट करके वो जगह डिसाइड की होगी, जैसे उस वक्त वो रोशनी होती है।
खैर वो एग्जेजरेट कर रहा है। रियलिटी है जो ये है कि जितने भी टेम्पल्स, स्टोनहेंज इज एन एग्जांपल, पिरामिड ऑफ गीजा इज अनदर एग्जांपल, मेनी एग्जांपल्स, उनको अलाइन करते थे with the sun and the stars. Especially the pyramids are aligned very much with many stars. I can't remember their names, but many of the stars are on a certain day, certain time, they are aligned exactly with these things. Because they had symbolic value, meaning something. So you are in essence, you have connected mathematics with reality. Right? And so this is the foundation on which everything is going to be built. So people started believing that mathematics has some real consequences. Right? So this is the story. This is the story. So this is the story of mathematics and reality. This is the history. You got it? So now, this, if you don't, this is very important. This is the foundation on which mathematics has now been connected with reality. Okay, so this is very important to understand. Now on this basis, mathematics now has become involved in our lives. Nobody is against calculation. You have to do measurement. Nobody is against, nobody wants to say that, oh, we will live in a how can you live without that? But does it mean that mathematics can lead you to reality? But that's how things started developing. So now what happened next is, once this notion started, right, that mathematics is somehow can reveal reality, the question now becomes, is that a fact? Is that something that is true? So up till the time of 18th century, this was not a question that people were talking about. This started after 18th century. And we will go into why it started after 18th century. We will go into that. So some of the questions that you have now in mathematics is in the philosophy of mathematics. This philosophy, usually people think, when they hear the word philosophy, they get scared. So there's nothing to be there's nothing to be scared about. Philosophy, translate that philosophy into, say, usul or foundation, because if you ask a Muslim, that's how it's going to be. What are the foundations of mathematics? What are the principles on which mathematics is founded upon? Okay, so now there are 1, 2, 3, 4. There are 5 basic questions on the foundations of mathematics. One is, these are all fancy names. That's why I have put descriptions in front of these things. One is ontological, metaphysical, semantic, epistemological, practical. I don't want to go into the details of these things. You understand, these are the questions. More layman questions are these kind of questions. People will ask, what is the role of humankind in developing mathematics? What are the sources of mathematical subject? and so on and so on. What is mathematical beauty? What is the relationship between the abstract world of mathematics and the real world, right? So this is the questions that we have. So when these questions were asked, these were three criteria that were put forward to make sure that, you know, the foundations of mathematics are what they are. So what are the requirements that we need for mathematics to describe reality? It needs to be consistent, right? You can't have an inconsistent set of principles, right? It needs to be complete and needs to be decidable, meaning that if you say something, you can decide in this system that this is true or false, right? So these are the three criteria you have for any system. And
Mathematics defines reality.
yes, defines reality. I didn't say that.
What did you say? I missed that.
Where? On which part?
Just now you said that.
For the foundations of mathematics to be accurate, to be sound, you need these three criteria. You need consistency, you need completeness, and decidability. In fact, these two criteria, decidability is a third something. You need consistency and completeness. These are the two main criteria. And what does Allah subhanahu wa ta'ala say in the Quran about it? About the Quran. Those two things Allah subhanahu wa ta'ala mentions for His book. He says, we have perfected your deen, complete. And if this was not from Rabbul Alameen, you would have found much inconsistency. If there were two ilahas, they will be fighting each other. So they need to be consistency. This is, I'm just putting it as a side note for us. So before I begin with dissecting the foundations of mathematics, what have people found in the foundations of mathematics? So here is a short list that I put there. These are the statements of mathematics that mathematicians of the highest caliber have come to the conclusion that these are undecidable problems that mathematics cannot solve. Okay, so these are, I have the years there. I can't go into the details of these things, but this is right there where it says undecidable problems in mathematics. You can't decide them in mathematics.
Question: if we're not going to discuss these, what are we going to discuss?
Coming. So hold on.
Maybe we can get an example of two.
You mean paradoxes? I give you one of the biggest paradox in Banach-Tarski paradox we discussed, remember? So I'll just give you one flare of Banach. This is one of the most baffling paradoxes of mathematics. It says, if you have a sphere, a solid sphere, it can be decomposed into two solid spheres of the same size. If this was 1 unit, this will be also 1 unit, and this will also be 1 unit.
So it will get doubled, you mean?
It basically, yes, in real life, meaning if you had $20, this becomes $20 and $20 and
Okay, then we break it into two.
yes,
But the same size, right?
of the same size, not half. This is real. This happens if you break this. This becomes half, and this becomes half. No problem.
Yeah, this is what I understood. No?
No, this Banach-Tarski theorem says this becomes 1 unit and this becomes 1 unit. In practical terms,
1 is equal to 2 units.
yes. So I can break this earth.
1 is equal to 2.
I can break this earth, and I can get 2 equal earths of the same size.
You agree?
I agree. 1 y is equal to 2 y. But I don't agree. 1 is equal to 2.
So this is a paradox. Paradox means in real life it doesn't happen. So either
Equal to 4.
this is what is going to happen. Either this theorem is wrong, right? Or the foundations on which this theorem was constructed is wrong. Only one of the two.
So I'm going to challenge the theorem, but I believe that maths is
So this is why it is called a paradox, because most mathematicians
chose.
choose to say this theorem is wrong, but the foundation is right. Some mathematicians have challenged whether the foundation itself is right. Because if the foundation is not right, that's why it's giving you such a nonsensical result.
What was the theorem name?
Banach-Tarski theorem.
Banach-Tarski.
On YouTube, there's a very good link. Tarski.
Tarski.
Here. Tarski.
Okay, Banach.
You,
I can send you a link if anybody has a.
is it the same equation, like the same guy who proved 2 is equal to 3?
No.
It's
According to this, 2
mathematical
is equal to
sets.
4.
No,
Mathematical sets. He used the set.
So on YouTube, a guy has, non-technically tried to demonstrate this paradox. You can look at it. So this is one of the biggest paradoxes in mathematics. This doesn't happen. You can't break something and have to equal. Except where?
gaseous is also the...
It's a quantum.
Except where? There, in that situation,
In financial markets.
no, hold on.
It becomes one.
There's going to be a situation in our lives. There's going to be a
Molecular
Hold on, let me finish my question. There's going to be a situation in our lives where once you eat this cookie, right, this cookie will become itself. It's like as if you had never eaten that cookie. You know where that's going to happen? There's a hadith on that in Jannah. That's the only place where it's going to happen. Where you eat, and like the hadith says, you eat a bird and the bird will fly off as if nothing has ever happened to it.
No, but mathematics is about this material world.
Don't confuse things. I'm just explaining things. I'm not saying this is material world.
You have to do some progress.
So, okay. So now, next. So we understand the paradoxes. There are some misconceptions about mathematics and its history. I'm not going to go into the details of these things. These are 10 basically. We are only going to take 2, 6, 2, 4 and 6. 2, 4 and 6. So 2, 4 and 6 are saying what? Let's look at what 2 and 4 and 6 are saying. 2, 4, mathematics is, number 2 says, is certain. What does 4 say? Are correct. And what does 6 say? Proof.
Unproblematic.
Proof is proof. I mean, proof. Once you prove something, it's correct. There's no problems in proof. We will dissect 2 and 6. We'll first go with. We'll tackle 6. We'll go to 2, and by the time we are finished with 6 and 2, 4 will be evident by itself. Right? If you say proofs are problematic and knowledge is not certain, then how do you know it's correct? Right? Okay? So let's look at, before we begin this, so this is some of the statements of mathematicians that have come about saying the miracle of mathematics in natural science and how effective mathematics is in explaining the natural world. So we have those. So here are 4 responses from Albert Einstein, Bernard Russell, and 2 other mathematicians. How does Albert Einstein answers these questions about whether mathematics is effective in explaining reality? He says, as far as the laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality.
What law is he talking about?
Mathematical theorems. He's talking about mathematical theorems. The laws of mathematics.
I didn't understand the sentence. But what's the value to the sentence? What's the weight to it? Any examples?
This is what he's saying. He's saying This is
We can put a question in another way.
Yeah, sure.
So when we say mathematics in natural sciences, is it talking about how things are created? Is it talking about how things
natural science, physics, chemistry, biology, all these are natural sciences. So
Yeah.
mathematics is being applied to them,
So when
right?
he said that
It's a very broad range. Maybe we need to.
it's
narrow
not
down.
certain,
Yeah.
the
Where
rule,
it
the
is not certain.
principles.
So he's saying if you are talking about the laws of mathematics,
Yeah, they are not certain.
if they are referring to reality, they are not certain.
Okay, I need to.
Okay,
Yeah.
I'll dissect this one. And then if they are certain, they do not refer to reality. So what does it mean? Try to understand this thing. So the Banach-Tarski's theorem we just said, I'm going to use that to illustrate what he's saying. He's saying, if you are sure that your assumptions of mathematics are correct, if you are certain that this is correct, right?
The bottom one.
If this is correct, if these things are certain, you are certain that there's no problems in there, then they do not refer to reality. Do you agree?
I think they're certain, and I think they're certain reflect reality. This is
So
what they
if
want.
Banach-Tarski, if the foundations of Banach-Tarski's axioms are correct, you know that you can break something and get two equal things. So they're not real. It does not refer to reality. It might refer to some abstract thing in an abstract world, but not in real life, right? And the converse is saying the same thing about in the converse. If you assert, if a law of mathematics, 1 plus 1 equals to 2, everybody agrees?
Yeah.
So
that's the law.
this is a certain law of mathematics.
Certain law, and it reflects
But he is saying,
reality.
then if you are certain that this is not an accurate reflection of reality. Now, what does this mean? He is actually saying, in actual reality, 1 plus 1 is not necessarily 2.
Maybe 2.01, maybe 1.9 in certain cases.
But he's not a mathematician.
He's a very first-rate mathematician. Einstein is a first-rate. So next one is Bertrand Russell. Bertrand Russell is the person who wrote Principia Mathematica.
Einstein.
Mathematica.
He was basically explaining Einstein.
But I don't understand what you're talking
About who? What?
about this uncertainty of principles and uncertainty of reality.
What is there? What? It's very simple. If you are certain that this is true,
I mean, what
Man-
do I can do the calculator to calculate my finances, and it's always right.
so
Calculator is always right.
yes, but
So-
it's not matter of right now. See, you are confusing two things. We are talking about ultimate reality now to describe the universe. You are not talking about day-to-day activities here. Okay?
Okay.
If you are certain,
Like if we are not certain when I go to the aeroplane, it reaches to the airport.
we already dealt with that. Allah subhanahu wa ta'ala brings you there. There's no certainty in the laws of aerodynamics. We did that before we left. So there's no, if you're talking about aerodynamics, there's no way you can tell me that aeroplane goes from A to B and because it obeys the laws of aerodynamics. No way.
No, we're not talking about some calculation.
Yeah, we are talking about ultimate answers. Okay, let me rephrase this thing. Here we are not talking about just 1 plus 1, one sheep plus one sheep gives you two sheep. And this is not what we're talking about. Reality is talking about the ultimate reality. How the universe began, why you exist. Where are you going? This is the reality. These are questions of reality. This is not reality that this exists. We know it exists. That's not a problem. You see it. You are seeing it.
So now can we take an example from natural science, a phenomena which has been described and mathematics is not proving it? If we can find that contradiction.
If you give an example.
Yeah.
Example of, I'm trying to understand your question.
This is one of the odd theory which says one equal size breaks into two equal size. We got it. So that's
Yeah.
one of the odds.
Yes.
Is there anything else which is in, say, physics or chemistry or biology as a natural science where math is not proving it?
Right now, I don't have an example, but I can think of some of the examples.
That's what we are trying to say, right? That mathematics.
So what we're trying to.
So
natural science
we
is not
see.
effective.
I understand. So you are saying you want an example outside mathematics where.
Application of mathematics
Okay.
into natural science, which
Give you an example from human population dynamics. You have Malthus equation. Malthus equation and logistic equation. What is it? P is equal to, I think, e raised to by xt, if I'm not mistaken, or something like that. This is how it defines population growth as an exponential, function of time. This was a total failure. This was a total failure. Malthus, when he came up with his Malthus law, as an example, I'm giving you. You give me the correct equation. I don't remember the correct equation.
I'm just typing.
Yeah, just stop.
Not typing,
Oh,
not,
okay.
Google.
Okay, and if somebody can give me the correct equation, that's fine. Otherwise, we can.
It's okay.
Malthus law, even today as we speak, this is the standard yardstick of the United Nations by which people, population dynamics is, being constructed. It's a total failure. I mean, we can, inshallah, next Saturday we will go into, the ideological foundations of, population, dynamics.
If we will finish this one, definitely.
Yeah. So let's not sidetrack this thing. I want to go to the main topic of today. Otherwise, these are a little bit more in-depth investigations. So a professor, actually from the University of Adelaide in Australia, he actually has written a counter rebuttal to this thing. So he has given lots of examples. I haven't elaborated the examples where he has shown that mathematics is ineffective to explain the natural world. He has some points there. We are not going to go into details of those things, but this, that has been already.
Electrical engineer, what he has to do into real world and reality.
Okay, let's go. There's another person another professor who is saying he's written a very good article. Mathematicians are overselling the idea that math is everywhere. It's a very good article to go into. We can't go into details.
That's fair.
We can't go into detail. That's basically what Einstein and other people are explaining. You can't have maths everywhere. Okay. Another he has listed all the points why maths cannot be everywhere is because if math were really everywhere, it would belong to everyone equally. And he has good reasons why he has written all that. Then the next one is by another scientist who has written Science's Cult of Calculation. The title itself gives the whole paper away. You know what is a cult, right? A cult is a negative connotation. We are a group. If someone calls us a cult, would you like it? No, because it has a very negative connotation. And see what the title he has put here. And it's we can't go into the details of these things, but I'm just giving you highlights that what people are writing against the idea.
If somebody don't like something or doesn't agree with the idea, can say this, right?
But he has to have a reason.
The reasoning is everybody has reason.
Exactly.
Everybody has
So
something good or bad.
So the question is.
Most will like it.
So that means the person who likes it will also say something and that is baseless.
No, I'm saying this logic of somebody saying something wrong and it's not proven properly.
What do you mean by proven?
Okay, so people are saying against Islam. What does it mean? Islam is bad? I'm just making
you are making a very incorrect analogy.
I'm not trying to compare. I'm just saying as an example.
No, people are writing against this whole ideological framework that mathematics can explain reality. Look at this book. Look at this book.
I don't have courage to read, but I can see it.
Can you see the title of this book?
Road to reality.
This is a 1,000-page book full of mathematics. The Road to Reality. I brought this book specifically to show you there are more than like this kind of thing. There are more than, at Amazon I did a search, there were more than 1,600 books of this type. Out of which, and by the way, I will just tell you a side note to this book. This was my wedding gift to myself. So,
I think for myself.
Thanks for making it
So that was
clear.
your second marriage.
so yeah,
he already
after-
planned to ruin his marriage.
this is what happened. I got, after like a month or so after I got married,
Because
I'd been reading.
Yeah,
I was waiting for this book to come out. So because I had been reading about it,
When
so
coincidentally,
I
your
worked
marriage and the release of the book happened together.
exactly.
So it's not your fault.
It's not my fault. So
so
So you are
Yeah,
mathematically it is correct.
I'm ready to take your case.
so anyway, the book when I remember I came to Canada with reading this book on the Air France flight, and everybody that I came across was saying,
Like,
"What are you reading?" I said, "I'm reading this. You take a look." And they said, "It's not. You will go ahead and read."
We're happy with our own little.
Yeah. So anyway, so let's come back to the point. The point I'm trying to point here is mathematics. You missed the first part of the thing. Is mathematics has been intimately connected to explain reality. And when we say reality, we're not talking about 1 plus 1 and counting.
the basic, basic
We are talking about reality is
outside, like, broader sense.
in the maximum sense that you can think of. Okay, so these are few examples that shows you that there are two sides of the story. One, people who believe that mathematics can explain reality, and there are other people, minority, who do not accept that mathematics can explain reality. These are also scientists, by the way. These are not Muslims or Hindus or theological people. They are scientists themselves who do not accept that viewpoint because it's an ideological viewpoint, is a belief, and they say that that belief is unfounded. So there are two sides to the story. We only hear one side of the story, right? We only hear one side of the story, correct? We only hear, what do we hear? We only hear mathematics can explain reality, right? Do we hear mathematics cannot explain reality?
Never.
So here, let's go to the proofs. The fundamental aspect of mathematics is proofs. So I want your undivided attention here so that we can finish this really fast. Proofs are the main reason why people love mathematics. Am I correct?
Yeah.
Proofs are the reason why they believe that if something is proven, right, that's it. Correct? So, like the example, with people looking at the interior of the earth, they will come up with mathematical proof and say that the earth is made of this, blah, blah. So, here we have a list of, so let's look at this. This is a basic, what grade are you in? Very good. So, what is the sum of the angles of a triangle? 180. Good. This is a basic mathematical theorem that everybody knows as a fact. This fact, right? This fact remain unchallenged for 2,500 years as a fact. For how long? 2,500 years. If you're talking about numbers. And then it was found out this is false.
But they're still teaching.
Why? Because this is true, but why is it false? Is based on an assumption, and that assumption is if this triangle is on a flat surface. I'm just trying to give you an example of proof and how it can be, become falsified later on. Why? Because if you draw a triangle, sorry for my drawing, this is longitude, this is latitude, right? And a longitude intersects a latitude at 90 degrees. Correct? Am I correct? So this triangle that is formed, ABC, actually has 180, 90 plus 90, 180 plus whatever this angle is.
45,
Whatever.
Yeah, 35.
Yeah.
35. That's something.
It's more than 180.
So
Are they straight lines?
these are curved lines.
That's why.
That's why you said this angle, a triangle formed on a curved surface will have angles greater than 180 degrees.
Or if it's a concave surface, so the angle is going to be
But this
Greater.
moon is is only for flat. It's not
greater.
for that.
Yeah, flat surface.
Yes.
Flat
It will be
surface.
narrower.
But not for if you draw
That's right.
see if you draw a triangle on
And this was the problem where they faced when they were
sorry.
trying to map the world flat, converting the reflection of global map into a flat surface.
So-
a great problem.
so we got that. So for 2,500 years, okay.
If we have if we have a flexible protector, can't we prove it the same?
Prove what?
If because you cannot draw a straight on a curved surface. Flat on a curved surface.
Locally it can be flat. Locally it can be straight line. Like right now when I draw, when I'm moving on a straight line. Globally, I'm moving on a curved surface.
Yeah, because the area you are covering.
Correct.
That is flat.
Correct.
Yes.
Correct. That's why we are saying on a flat surface this law holds. On a global surface this law does not hold.
I mean,
yes.
it's the degree of curvature
Exactly.
affects the degree.
So
of the angle.
if you are talking about curvature, this is what happens. If the curvature is less than 1, this one curvature is 0. I can't remember. I don't want to give you incorrect one. At this time, I can't remember this thing. So anyway, we got the story. And if you draw a concave one, you will have less than 180 degrees.
No, it's more than.
No, this was one more than.
No, if convex, on convex it's less.
Yes, on convex,
concave, the
it's
angles
yeah,
are
correct.
greater.
Yes. So let's come back to the point. Let's not go into the details. This is what happens. So pause here. You are so used to this being told to you that when these kind of notions come, it's difficult to understand and absorb. Right?
Yeah.
So, coming back to the point, a theorem that stood for 2,500 years was proven to be wrong. Right? So, mathematics is not infallible. Theorems are not infallible. Just with one example. So, let's go to another example.
Can we call it rather than it's possible, but now they have added a new definition to it that it has to be flat surface.
Yes.
That's the whole idea.
That-
Factors which were not considered for thousands
They
of
added
years.
it wrong.
So, let's come to another.
Rules are basically for a particular frame of
Now
reference.
Two,
imagine
three.
we've been using this
Particular
triangle technology to measure the distance, For
So-
instance, you get the angle.
Okay, so let's look
Two angles,
at this thing.
tell you the
A square
distance of
plus
this
b
point
square
to this
is
point.
equal to c square.
And then when you
Yeah?
do this,
You seen this theorem before?
Yeah,
Pythagoras theorem, no? A square plus b square is equal to c square.
This is-
Pythagoras theorem? Yeah.
oh, हम और एक level पे.
So this is the famous Pythagoras theorem. So mathematics is about generalizations. So format the French mathematician, he came up with this: an plus bn is equal to cn. I'm putting my words, but actually he had written as a x whatever. So he wanted to prove the most general case.
So
Right.
that means instead of n, we can put any number.
Any number. So instead of, you know that this is true for n is equal to 2. Is it true for n is equal to 3? Is it true for n is equal to 4? You know, and so on and so forth. And the proof will be that it should be true for n raised to n plus 1. You know, that's the mathematical induction. So anyway, so what happened was this. This proof was lacking. You could calculate it physically and say it is wrong. You can calculate it physically, it is wrong. But it was calculated to, I think, million index or more, and it still was just wrong. But there was no proof. There was no proof. So Andrew Wiles, I believe that's his name, he came up with the proof in 1994 or 5. I can't remember. That's when, something around that, in the 1994-95. And this proof was 500 pages long, with some very complex mathematics. Even the mathematicians of the time, he invented fields in mathematics to prove that an plus bn equals to, it's called Fermat's last theorem, by the way, if you want to do a Wikipedia search, last theorem. Okay? So now question, we are talking about proofs, so we are spending more time on proof. We are not going to go into, if this mathematician, when he had 500 pages with the new mathematics, right? You know what the initial reaction of people was? How do you know it is true? It's only known to one person. You following, Brother Fawad? It's known only to one person. So how do you know that this proof is correct? You have to believe him, right? And you believe that he's applying the rules of mathematics correctly, because you can't verify it. So it took many workshops, many seminars by Andrew Wiles and some of his colleagues to explain these 500 pages. Somehow it has become accepted that his first try, when he did it, wrong. And step number 300 something was wrong. So he went back and he hid himself for 2 years, not talking to anybody, to come back with another proof. And then, eventually, now I don't know whether it is correct or not, it has become accepted that it is correct. Do you see where I'm getting into? Okay?
But that acceptance must have some restrictions also.
Let's not go, just keep following me.
For common person, this is up to you.
Now, Andrew Wiles, yes. So now let's go. Now we have come with there's another Japanese mathematician who has come up with one powerful,
With all the rules.
what's his name? Shinichi Mochizuki. He has, about 4 years ago, he came up with for a proof of a theorem, which mathematicians have been looking for, and for the past 3 years, that is December 2015, up till that point, nobody could understand his proof. Nobody in the world, no mathematics. Conferences, seminars, workshops have been done so that people can understand his proof. So far, as I speak, no one has been able to understand his proof. So whether it is correct or wrong,
So what's that about? Is that about the same?
no, this is about something else. So completely different field altogether. So the biggest mystery in mathematics right now is, how do we know his proof is correct? Okay, so now with this advent, other proofs have come which require, did I put that one there? Yeah, so I'm just going to go one step forward. the Monster theorem required 15,000 definitions, 4,300 lemmas. Lemmas means theorems. Okay. And how many? How many gigabyte is that?
3.
Where is that? So far 6 books, 10 that one. Well, I forgot. Did I forget to
On the
put?
previous page, like here,
Some may feel this is called the. It filled 255 pages.
here 3 gigabit with about 3 gigabytes of
Okay.
calculation.
So here we have 3 GB of worth of steps. I'm asking you unbiasedly, do you think any single human being can comprehend 3 GB of data? Brother Fawad, what do you think? Do you think 3 GB of data any single human being can absorb? Sorry.
Depends.
You think somebody can do that?
It depends.
I don't think so. I don't
For
think.
instance, if you take an eye, the pixel or eye generate is around 100.
I'm talking about the mind. I'm not talking about the eye. I am asking you, I give you 3 GB file, and each of them, each line has some semantic meaning. Can you go through this 3 GB of data and come back and say, I've understood everything?
If you
How are you going to quantify 3 GB? Like people.
I understand. I understand. You have gone beyond that.
People
So
learn Quran, so this.
I understand. You have gone into the philosophical dimension. So let's leave that one alone.
if it is in a step based, like if you are going through certain
Okay.
steps,
So let's assume that a person can understand. How many people do you think can understand this thing? How many people do you think can understand this? Not many people. So you have to believe the expert, right? So this is not all. This is just the begin. So we have, let me summarize this section so that we can go on. So we had a proof. We had one that failed. One that was long and complex. And one that was extremely long, extremely complex, right? So there are 3 cases. One that failed, the theorem of the triangle, right? It failed. Fermat's last theorem was, the proof of that was long and, 500 pages. This one, the Monster theorem, is extremely long. Oh, the Japanese mathematician one yet to be verified. Right? Okay. So let's see what else proofs are there in mathematics. So this is the condition of proofs, right? So let's go to the next one. This was the other one. Okay. This proof, there's a proof that requires this many symbols, 1000. And there's another one that requires 10 raised to power 10 raised to power 1000 symbols. And this is assuming, there's a big assumption there, but let's talk about this thing. This is the number of symbols required for this proof. And this is this one. This is, what does it say? If you could take all the protons in the entire universe, you will not be able to write this thing down. And forget about this one.
There's a method. For instance, like when we design silicon chips, when we write long software, operating systems, right? Cloud-based applications right now running, taking care of data. So you don't go into every detail.
But
You have methods to,
Okay, hold on. We are not talking about the application here. We are just talking about proofs in mathematics. A proof, by definition in mathematics, requires certain steps, right? And you say that this is proved, correct? If these many steps are required, then you cannot prove that statement. Very simple.
So it's you're telling me that this is just an excuse. Nobody's gonna go there, so it's just
Why?
it's not physically possible. This is what you're saying, right?
It's not of course it's not physically possible.
Is it the same guy who was out for
But
2
if
years?
you if
No,
you use,
this is different. This is the other theorem.
you use computing power of multiple terafolds per second, you can calculate.
How can you calculate this thing? If you require this many symbols, and if we're just saying that if you write, this is more than the number of protons in the entire universe. How can you write this thing down?
The way you wrote it. There are shortcuts to write things.
So does that mean that? Okay, hold on. Am I in America? Am I in America? I wrote America. Am I in America?
No.
So
You are North America.
India. Am I in India?
Red India, yeah.
So anyway,
What are you trying to tell me?
just because you wrote that down doesn't mean that you have proved it. You right? Okay, hold on. I don't understand your question here. If I have to prove something, I have to say this. I have to make statements, and then I say QED. If you are, what needed to be proved. This is the case. This is how mathematics is done. If you require 10 raised to power 1000 lines, how are you going to prove it? I mean, I find it difficult what's so difficult in understanding this thing?
The thing is, we don't understand what that
That's what I'm trying to understand. What is it that you are not, to prove something, you say one statement, 1, then you say 2, then what follows is 3, then this implies 4, and then this implies 5, and you say 7. For instance, all men are mortal. Right? Socrates is a man. Therefore, Socrates is mortal. This is a deductive proof in 3 lines. We follow? This is the first statement, the premise. This is your, statement, and this is your conclusion. This is how mathematics goes. Instead of, I put it in English, in fact, if you look at it in mathematics, it is P implies, all those, shorthand symbols that you have. If this thing that you have started requires 10 raised to power 1000 lines to prove, that means you can never prove it. It's very simple.
Sorry to join late, but this is an assumption that is gonna, if I'm going this way, so after this many steps, it should be proved.
This is not an assumption, that is what that is saying.
There's an assumption. He didn't go that far.
No,
He didn't go that far.
it's not an assumption.
Even he
It's,
can't go there.
sorry?
He's saying even he can't go there.
He's saying if I make a statement X, okay, to prove X, I require this many steps. This is all he's saying.
But how did you find out this number?
That's a different question altogether. That's algorithmic theories. Believe me, you can come to this number. There's no problem with that. Okay? Now you are going to say how did he come to that number? That's a different discussion
Where did
altogether.
he get this number? That's the
So
question.
that's a very good question, but that's a different. I can't go into that right now.
Because he did solve this using that many steps.
No, he's actually, of course, he's not going to solve it, but the method he's going to use.
He didn't go that
Okay,
far, right?
okay. You are a computer.
He didn't go there.
Okay, let me ask you this: a linear search requires how many steps? If you have 3 elements.
999.
To find B, worst case, C, linear search would require how many steps?
3.
3,
3.
right? Am I correct?
Just 3. Linear search.
Linear search. It starts with A, false, B, false, C, correct. So 3 steps. That's why it's called linear, right? So if someone tells me that I have a string of 26 letters, how how many steps does a linear search require?
28.
27. Right? 0.
0, 4, 6.
Right? Similarly, if you have a statement, and now I'm going to, in arithmetic, it's called IONA arithmetic, you can, based on what the steps that you have, based on that, you can calculate how many steps you require to come to a valid conclusion. Right? Just like how you came to a conclusion, you didn't actually go through it, did you? You didn't. You just know that there are 26 symbols, and linear search is this, therefore I require 27 steps.
That's how we do n plus 1. To reach to n, you need n plus 1 to.
So
n plus
if it was binary sort,
Yeah.
you know how many steps you require. And you have all the algorithms, the search algorithms. So this is just similar to this. You are not going to actually calculate. You can't. Obviously, you can't. But you can. Calculate, project how many steps is required, right? Based on those things. The next one is what? 10 raised to power 10 raised to power 1000. Obviously, we can go on, and the next one is actually a stack of tens. You can even go on. So basically, what does it mean? Can you trust a mathematical proof now? Can you? No, you can't. Based on what we have just gone through. Forget about everything else. Based on what we have just gone through, can you trust a mathematical proof now to be absolutely certain truth?
So our reality is based on our senses. Simple formula.
So that's
The senses that
no. Go.
observe, usually we
So you are answering the question from a different dimension. I am restricting my question to this presentation. Can you trust a mathematical proof to be 100% accurate now?
No, of course not.
This is one category you're talking about. Long,
Of course. I'm talking about longer proofs. Yes.
extra, longer proofs.
Yeah.
But there are other types of proofs too.
This is a very complicated topic. I can't even begin to justify this. I can't even explain this one. This one basically is part of the halting problem, undecidable problems, and this one is very difficult for me because that paper itself was very difficult for me to follow. So it's saying if you have two models, model 2, and you give the same set of instructions. This I may be a little bit off here because this was very technical paper. I have to go through it at least 3-4 times before I can understand this. But basically this is what it's saying. If you have one model and another model, okay? I didn't explain to you models, so perhaps you guys will find difficulty in understand this thing. So let me just pause a little bit here. Remember that triangle that we talked about? 180 degrees. So this is your normal Euclid geometry, in which it is greater than 180. It's called hyperbolic geometry, and then you have another one that's called elliptic geometry. So what happened was when that assumption failed, when that theorem failed, you have people. Now that was the first thing that was found in mathematics. From one geometry, we came to many geometries, right? With this analysis of proofs, we came to understand that there's not one arithmetic, but many arithmetics. Okay? Please don't confuse day-to-day counting with this thing. Okay? That's the difficult part here. So, and then we came to, at the same time, not one algebra, but you have many algebras. Which leads you to Not one mathematics, but many mathematics.
So these are the branches or different?
This is,
So you're going to the model?
so this is what is meant by models here, okay? So this theorem that you have up there, this theorem that you have up there, okay. So this theorem that you have up there, hey, you can so I put this one here. So this theorem basically is saying if you have a model here and you have a model here and you give same set of instructions, what is going to happen? The output here might be output 1, but on this one it might be output 2, which is very weird. So meaning things are becoming more complicated because then you have to find out what's happening, okay? So that's another aspect of proofs. So verificationism was one aspect of logical positivism that came out, and this is what one of the proponents of verificationism says. What did he say? He said nearly all of it was false. This is a person who promoted it and then later on found that you can't verify things. Sorry?
Both sides are false.
No, so we are moving to a next topic. Okay, so let's erase all this. In the history of science, there was this concept of if you can't verify something, then you are not going to accept it. Then there were some rules by which you verify things. If they do not meet these rules, then those things will, you neglect, you exclude from science, right? So this is what they're talking about. So what I'm trying to say here is the people who founded this principle, they themselves later rejected it because these principles could not be met. So then you have to exclude all of science, for instance. So they said these rules we are not going to accept.
But idea exists.
That's where an idea doesn't die. An idea is a belief and it never dies. And what do I mean by that? Do you know that people have, after how many years? 10 centuries? Or is it 10 centuries? The Greek god, the temple to the Greek gods has been reconstructed. And they are reviving the old Greek, pagan religion in Greece. So did the idea die? You think so, right? I mean, think about it. The Greeks were so long ago. Christianity has replaced them. Modern world has replaced. But the ideas never die. Just to give you point, the idea of verification. In principle, people are not accepting it. But the idea is not dead, and that's one of the problems. Is we also fall into that trap of verificationism. So here's a paper about.
But this is a very prevalent understanding that whatever science we have, it has passed the test of verification. And
we can discuss that. We have been continuously discussing that, and we can continue to discuss that. I just brought it up here in relation to the foundations of mathematics that not everything is verifiable. That's very simple. You continue accepting it. You accept those results without verification. That's it.
In reality.
In reality.
In the
in the practical world, yes. So,
More examples, can I give you some examples?
example of what?
This thing you just said.
Belief in mathematics. That mathematics is the road to reality. Here you go. Here you go. Isn't it a belief? What else can you classify this as? This is what we're discussing. The belief that mathematics.
आप डरा रहे हैं मतलब बता तो नहीं रहे
But
डरा दिया आपने
but this is the belief. This is the belief.
पता है पड़ेगा नहीं
पढ़ेगा नहीं. But let me ask you guys. This is a 1,000 page book. This is a 1,000 page book that this guy has written. It's full of mathematics. Look at it. It's full of mathematics. Isn't it? We forget about mathematics explaining reality. The foundations of mathematics are hollow. We just went through them. And he still persists that mathematics can explain reality. Isn't that a belief? I can't change that belief. He has to change it himself if he wants to. But I can't. You are asking an example of how people physicalism. Remember physicalism? We discussed that, right? The belief that everything that exists in the universe is physical. Isn't that belief? It's not. For the past 4,000 years, this people have tried to find a physical reason why of life, physical origin of life. Remember we did that. How many papers are being written on the physical origins of life? Countless papers. There's no evidence whatsoever. Have people stopped believing physicalism?
But there are scientists or mathematicians who believe that this mathematics it has an issue.
Exactly, and those are the ones.
This guy doesn't believe that.
So yes, we pointed those ones out. So good point here.
Including Einstein.
So Einstein is one of them. But Russell
He
is
said mathematics is a belief. Did he say that?
no. He didn't say that.
We spoke about knowing
We will come to that quotation again.
He said mathematics.
certainty of laws gives us reality. Is it either you believe one side or the other? Both can be true.
So basically, let me just address this point really quickly. There are two in relation to foundations of mathematics. There are two camps. One that believes that the road to reality is through mathematics. Okay? And there are others who believe that the road to is not through mathematics. These people, I'll just show you. However,
And through what?
okay, good question. This camp doesn't have an answer.
They're looking for the answer basically.
Yes, exactly. That is why nobody hears about them.
And actually Einstein was is from that camp.
Einstein is here.
Here. Okay.
So let's forget about Einstein. So these are some of the myths about mathematics. I can't go into why people understand this statement. Why do people believe that the road to reality is through mathematics? This is a myth. This author says. So he's from this camp. He has gone through, he's a professor. You can see that all the professors and all these people are there. We can't go through all the details. That would require a separate session about the myths about mathematics and the sources of mathematics. So we can do that some other time. Is mathematical certainty absolute? So we come back to your question. Our question: does mathematics, when it says some statements, are they absolute? Are they certain? Right? So this is again related to the myth that we have created about mathematics, that it is absolute, it is certain. We just went through the proofs, that we saw a proof that failed because the underlying assumption changed. Therefore, it cannot be absolute, it cannot be certain. So he's of that camp.
This is, the context is ultimate reality,
Ultimate reality.
not day-to-day calculation.
We are not talking about one sheep plus 2 oranges. We are not talking about that. So this is another example. This is somebody from, I think, Finland, and he started his I think his PhD or his whatever dissertation with this quote from Hume, who is a British philosopher, and he's Scottish philosopher, and he's one of the philosophers who actually shapes modern world. So many people quote him, Brit Hume. David Hume was, what is his name? Hume, I just remember, I always forget his first name. So
Last name is Abu Academy.
Abo Academy, yeah, that's Finnish or something.
That's okay.
That's a university name.
But now
So this is another same thing about there, the certainty of mathematics. This is actually a 159 page paper. So it's talking about whether the certainty of mathematics.
Question कहाँ से start किया? ये program मतलब ये lecture.
Oh, the lecture.
You can continue. I can show.
So the next example is what's the ideology of certainty in mathematical education. So we have that. Next one is, this is by far the best example of a paper on the problem of certainty in mathematics. And so I'll just read you a few lines here from here. It says what? An outstanding controversy in mathematics and its philosophy concerned the certainty of mathematical knowledge. The traditional, received, and even standard view is that mathematics provides infallible certainty. Mathematical knowledge is absolute and eternally true and infallible. Right? Am I correct? You guys, do you believe that mathematics is true forever? Do you accept that? Do you accept 1 + 1 is always 2?
Yeah.
Could it change?
No.
No. See, this is how we grow up. So we relate these concepts and project them to the reality, and this is where the problem has started.
But what do you mean by reality?
Reality means, when we are talking about reality with a capital R, there are 3 questions that needs to be answered. 3 questions. Why we were created? What's the purpose of our creation? And what happens when we die? This is reality.
This is reality.
Because it is why is it called reality? So let me just explain that a little bit. Let me
Who
explain.
says it's reality?
That's what reality. That's what we refer to reality. This is what. So
Who says it's reality?
okay, you can say that's not reality, but that's your reality. These are the 3 questions that you need to answer.
So other
do we have
people
some
agree with that?
Everybody agrees with this. There's no human being who will disagree with these 3 statements. It's written in English language. It will be rephrased differently in Arabic, and it will be rephrased different in Sanskrit and versus in Chinese. But this is it. This is so. The first, why is this so fundamental? If this is not fundamental, none of us here, I can tell you, will be here today. Why?
Yeah, this is basically actually the question of every person, every creation.
Yes, whether you are implicit or you are explicit. Implicit means you do something without actually asking the question, and explicit means you explicitly say it. Implicit is what? A person, and this I'm not making this up, a person, a boy of I think 25, 23 years old, he wrote a 300, if I'm not wrong, 356 pages of suicide note with footnotes and citations.
It took too much time.
He wanted to prove that his suicide is not just for vain.
Yeah, that's the point.
That's the point. That's the point. That's the point. So why did he commit suicide? So why did he commit suicide? With footnotes and citations, giving references.
With citations.
So why did he commit suicide? He committed suicide because after coming to this conclusion that there is no purpose, I don't have a purpose. There's no
That's
purpose.
why it should be.
And he said,
After committing suicide, he must have figured out, oh man, that film was wrong.
I'm not making this up.
Yeah, no, that's right. But he could not find the conclusion. That's why he ended up in
Correct. So let me put it in this. I give you an example. Let me give you a mundane example.
So
Why do
Robert Penrose?
Roger Penrose.
Roger Penrose. He also believed this three question of
Yes,
reality or
yes. That is his introduction.
Basically, he's right. This is a general question which, when we grow up, it comes in our mind.
So let me give. So this is an intellectual thing that I gave you. But let me give you a mundane example. Mundane meaning daily example. Why does somebody get up, go to Tim Hortons or a warehouse or a IT job? Why? Why do you get up and do that? Because
If someone transfers a big amount of money in my account, I will stop doing that.
so that's
You don't go
it.
anyways. You stay at home.
But even then,
No, I will go to Hawaii
why do you go to Hawaii?
to enjoy my life,
Why are you enjoying your life?
to have fun.
Why do you want to have fun?
Yeah.
So you see, ultimately,
Okay, I change my destination.
ultimately, you will come to this question: what is the why do you want? Okay, let's look at this example. You guys, especially,
Maybe.
I want to have fun. This is my answer. Everybody wants to have fun. Why do you want to have fun?
Because fun is good.
Fun is good, but why is it good?
It interests
We
me.
enjoy it.
Let them
So you see, you're going in circles.
Addressing them.
So hold on. So you're going in circles. You will go in circles. Very simple. If you do not have a purpose, you will get up in the morning and shoot yourself and say, that's it. Because why do you have to feel the pain of going, waking up, brushing your teeth, looking good? If somebody says, hey man, your clothes look dirty, and you feel bad. Nobody wants to feel bad.
without writing a note.
Without writing a note. In fact, without writing a note. Without writing a note. So, why were we created? Why were we created? What's your purpose? We were created to worship Allah. And this is the purpose that drives us and gives us meaning. And where are we going? Remember, where are we going? What is the happiest day of our lives? What is the happiest day of our lives? So, it is going to be in Jannah. There's no doubt. Why?
That's afterlife.
That is life. This dichotomy, so just I'm going to hold it here. This is a very important thing, so I'm going to just do this. In Islam versus this is the whole problem of physicalism. This is what happens. So this is, you come from Arwa. We don't know anything about this. This is the world, dunya. We go to our graves and we go to Jannah. This whole thing is life. There's nothing called life like this. This is a totally materialistic, physicalistic concept. This is बिल्कुल सही गलत है. मर गया बेचारा इसलिए कि दुनिया में उसने कुछ नहीं किया, इसलिए बेचारा।
मर गया बेचारा।
जो मरता है वो
आगे जाके वो मरेगा
कुछ
बेचारा।
करना है।
इंतकाल होता है, इंतकाल।
मुंतकिल हो गया।
He has moved from this place to this place. Mind you, just to give you guys this thing here, in English language, you refer to a person as late Mr. John. You have heard that expression, late? Why do you say late? Why did people use late? You know why they use late? Because he is late to our gathering. He's here. This was the concept behind late.
He's not late, he's missing. He never came. He never came.
So,
He's early.
so okay. Let's go back. Let's go back because the kids are here. Very important. This is life. You start from here. Your soul starts here. It goes to the dunya. It goes to the grave. It goes to Jannah. This is life. If anybody tells you anything else, then he's he's fooling you. He's deceiving you. Period. There's no doubt about that. If someone wants to say this is only life, then he has some serious problems. He has some serious problems. And he needs to be, this kind of people needs to be taken to a medical doctor so that we can, retrain them.
Is there an option Jannah or there is another option?
We will not talk. In our gathering, this is only option.
Inshallah. Inshallah.
There's no other option. There's no other option. If you have iman, and when I say iman, we're not talking about Islam here. We're talking about iman. If you have iman, this is the only place you are going to. No doubt. So that was a digression. So here was these are papers are written about whether mathematical knowledge is certain, and they disagree with that. So this is another example of a paper that was written by another mathematician.
You can distribute, we all need it.
It's called The Illusion of Mathematical Certainty. So here are some books that question the certainty of mathematical knowledge. And then finally, I think I have won this question, why we have the centrality of mathematics in the history of Western thought. This is if you really want to understand why mathematics is playing such an important role in modern thinking, this is one of the finest papers that I came across. I can't go into details of this, but I will address it after we are there. And the last slide I have here is, this is an issue of 2016 New York, what magazine is that? New Yorker. It says, are we really so modern? And you can read the subtitle yourself to answer the question. Last slide is this quotation that, please look at it carefully. This is what Arthur Eddington saying, proof is the idol before whom the pure mathematician tortures himself. Okay, do you get it, or do I need to explain this?
Good to explain.
Good to explain? Okay, here we go. He's saying this. He's saying mathematicians have made an idol, and that idol is called a proof. Okay, and to worship that proof, to worship that idol, the mathematician goes through torturous processes just to please this idol.
Like writing this book.
Like writing this book or reading this book.
That's better.
Because I personally have found it.
And I just found one contradiction here. Mathematics is all about deductive reasoning, right? Am I right?
Mm-hmm.
But here, what you said, they agonize themselves the whole life just to prove that mathematical myth. This is basically inductive process.
Okay, we will go into that some other time. Okay, so
जवाब किसी ने बड़ा अच्छा भेजा
so
पढ़ दूं
Let me finish this, then I want you to finish, put the icing on the cake.
2-3 minutes before.
So this is the last one we have. As far as the law, Brother Irfan, this is Albert Einstein's statement. As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. So I think that these quotations encapsulate that. Brother Irfan has something.
No, somebody just sent
Read it.
Lucky relating to this, it says बहुत ज़्यादा इल्म के मुकाबले में थोड़े से अदब की ज़रूरत है.
सही बात है. And the last one, Brother Fawad, do you remember that one?
Which one?
फलसफी की बहस में.
फलसफी को बहस में खुदा मिलता नहीं.
आगे
है
सीरा सुलझा रहा है, डोर सुलझा रहा है, सिरा मिलता नहीं. So here, actually, this point here, see here, there's a incident here where the mathematics teacher actually says, the student tells the teacher, I never realized mathematics was like this. Why? It's like philosophy. So, conclusion, here, understand this: mathematics, science, technology, and then you have philosophy. What is the relationship between all of this? Or there's no relationship? Brother Fawad, what do you say? You have mathematics, you have philosophy, you have science, and you have technology. What's the relationship between them? Or there's no relationship? I want a quick answer. We want to wrap it up.
Science is the tool to get to the technology, and philosophy is the mindset.
So I think Brother Irfan has encapsulated. Basically, philosophy sits on top of all of this. That's it. If you don't have a philosophical outlook, you can do mathematics, you can do science, you can do technology. And this is what Muslims have totally forgotten, that you need aqidah, you need ideology before you can do this. It's not the other way around. So that's basically was the short encapsulation here. I have a question for you guys if we are done. So I want to have a question. I have 2 questions. Are we finished? So can I, always open to questions. If you have questions, you ask me, and then otherwise.
Multiple choice answers?
Yeah?
Multiple answers or single answer?
No, I will ask if nobody has a question.
And what's the incentive?
Incentive for what? Incentive?
Yeah.
Jannah.
Yeah, wow. Let's please go ahead.
Go ahead.
Everybody fight for this.
See, I will tell you guys, the kids are here, so I'll tell you my personal story, how I came to this thing. I wanted to study mathematics. I wanted to be a mathematician. But my dad and especially my dad, they wanted me to be a doctor / engineer or something.
So his philosophy was different.
So, yes. So, the compromise between my dad and myself.
Philosophy was different, but mathematics.
So the compromise was that I will study computer science or computer engineering. That was the compromise, and so I study this thing not because, with your question, I do not study this because I think I'm going to gain anything out of it. The only reason why I study this is because I want to clarify my iman, so that we can all go to Jannah. Period. There's nothing else to talk about.
But the issue is that when people start reading those kind of stuff, a lot of them become atheists.
Because they don't see.
I'm surprised you have such a great iman. I mean, I know many of my friends who studied that detail and they are atheists now.
What
the reason is. The reason. Okay, so I'll give you a personal.
reality.
So I'll give you a personal incident in my life, which was it really shook me. I think this much age, if I'm not mistaken, or a little bit, no, your age, actually younger. So on my summer vacation, I went to my dad's, college library and I decided to study. And what did I pick? I picked up 11 volumes of Encyclopedia of Philosophy and Ethics. So I studied it. After going about 1 volume or 1.5 volume, I stopped. Why? Because it was taking me away from Iman. To approach these subjects, that's why I'm going to connect it to the Seerah now. The reason why we are in this situation is because we don't follow the Seerah. What did Rasulullah sallallahu alaihi wasallam say to Umar radhiallahu anhu when he came with the books of the Ahl Kitab? He said, stop reading it. Don't you know I have the message? It is when he understood the message of Rasulullah sallallahu alaihi wasallam, then again he saw him with Umar radhiallahu anhu with the books. He never objected. Why? Because by that time Umar radhiallahu anhu was able to internalize this statement which he made when he was a Khalifa. This statement that I'm going to tell you is, there's a debate about the authenticity, but regardless of the authenticity, I think it's very valid. When Iraq was opened, some books were discovered, and they were attributed to the prophets Daniel and of those times, and they said, what do we do with these books? So they wrote to Umar radhiallahu anhu. So what did he reply? So he said, burn these books. The first part is you cannot really get it. He said, burn these books, because if these books were telling us about the Akhirah, then we have a better book. Everybody got that?
Yeah.
Everybody got that? He said, burn these books. If these books were telling about the Akhirah, the Ghaib, then we have a better book. Next statement. And if these books are talking about the dunya, burn them, because we shall discover them again. This is human knowledge. You will get it, if not today, tomorrow you will get it. The central thing is from the Amr al-Arwa to the dunya, to the grave, to Jannah. This is the question. What is 1 plus 1? If not today, tomorrow I'll do it. We will do it. That's not a problem. It's no big deal to write mathematical equations. The big deal is, why do you exist? Who put you here? And where are you going? Are you going to stand before Allah? Are you going to be held accountable for all the things that you have done in the dunya? That is the central question.
Any question? You're asking a question.
Okay, so my question is, if you guys don't have a question, I have a question. Why do you think mathematics play such an important role? So we can close this down, I think.